Alright, so welcome to digital class for introduction to programming. So this is basically um, for the second topic. So this topic basically talk about problem solving concept. So before we can start real programming, before we can start mingle in source code, we need to understand how the process of translating problem into computer code. So this topic will look into that, trying to build the fundamental of computer programming. Alright, so basically the most important thing in writing a software is basically for computer scientists is basically problem solving, the ability to solve problem and translate the problem into a computable program so that the similar problem can be solved using the same software or the same program. So the ability to formulate, to turn problems into software solutions, into computer program is very important, so that user can have a good solution, a good quality solution. So basically, before any programming, or before any software engineer or the programmer write a software, they need to understand the problem. They need to be able to solve the problem first before uh, translating the problem into computer program. So that is very important step in any programming. So the ability to turn any problem into solution, and then the proposed solution into computer program using programming language, or any programming language such as Java or C++ or PHP. Any programming language need the ability to turn the problems into a computable solution. So as a programmer or as a system analyst, the ability to think, to turn problem into solutions and into computable solutions is very important. Alright, so before we can turn any problems into computer solutions, so we need to understand the problem. We need to look into the problem and how we can turn the problem into what we call as a computerizable solutions. Right, so basically when a computer scientist or a programmer look at a problem uh, in computer science, is basically the statement of the specification that requires a solution. Okay, so any problems will require a translation into statement, into instruction, so that that instruction can be turned into solution. So there are basically two type of problem. We can divide, either it is a concrete problem or it is an abstract problem. So basically when we have a concrete problem, so concrete problem basically the what we call as the value, the solution is known, is being given, the value is concrete. Okay, what is the diameter of the moon, or when we have a football, the ball, the diameter of the ball. okay, the radius of the ball. So it is basically a known value. So the value is known. Okay, so it is basically easy to identify. So when the value is given, and then just calculate or just compute, for example, the area of a circle when the radius is 5.5. So it is very concrete problem. Or the value of, for example, the second example here, Ali drove to Abu's house at 60 km per hour. So Abu's house is actually 80 km away. Ali arrived at Abu's house at 3:22 p.m. So what is the time did Ali leave? So we can basically do some computational value, but the value is already given. Okay, it can be solved, but the solution only for that particular problem. So in other words, it only solve a specific problem. It cannot be turned into a general problem. Okay, so can only solve one problem. But in a computer science, in the computer based solution, normally we are looking into an abstract solution, whereas the solution can be used, it's not been determined, the value is not been determined. User can input the value to the application, and the application can calculate based on the value given. So this is where the abstract problems. Alright, so basically they have no particular value in abstract type of problem, and it is being used in making the solution. Okay, so for example, so the same idea, compute the area of a circle with a given radius. So there's no value for the circle radius, and then it is a general statement. Okay, so user can input the value and get the value for the area. So this is more what we call as a generalized or abstract solution that can be used in programming and in developing a software. So we have an abstract solution, and also the same with the second one. The value is only given at 60 km per hour, and then Abu house is 80 km away, and then the application should provide the time that Ali live at certain particular time. Okay, although there are some parameters given, but the solution is abstract. The third one, this is much more clearer, whereas to calculate the monthly payment for a given loan amount with a specific loan duration and interest rate. Okay, there's no value given here, where the user can enter the value with any value that they are interested in. So it requires an abstract or general solution which can solve many problems. So user can use the application to solve their problem, not for specific person. Okay, so abstract problem are more common problems. So application that we develop tend to look into this kind of problem. Alright, so when we have problem, we need solution. So how do we present the solution? So there are two types basically when we look at the solutions, how we present or how we translate a problem into a solution. Alright, so again, there's not yet any programming involved in this stage. We are basically trying to translate the problem into solution throughout the what we call as the analyzing the problem. So the first one is algorithmic solutions. So we turn the problem into algorithm. So this is basically when we have a problem, we need to translate that problem into steps, how to solve that problem. Okay, so we need to turn that into Okay, so the first thing to solve this problem is A, B, and then next C, next D, so on and so forth. Okay, so we have the steps. So this step basically involve a following sets of instruction that we can translate into computer codes. Okay, so for example, calculating your checkbook balance. Okay, so calculating your checkbook balance, so the first step is to do what? Okay, so you want to check your account number. Okay, or you want to check your, even if this is for your ATM system, so you need to enter the card first, you need to enter the password, and then you need to select certain menus before you can access to the checkbook balance. So that is basically the steps. So they need to draw that step first before trying to develop the ATM machine software. And the solution must be the same. It should be the same every time, so that other user that trying to access the checkbook balance will follow the same step. Okay, so it must be the same for everybody. It will not change from one person to the other person. So most computer use algorithmic type of problems, translating problem into solution. We are basically looking into steps. So algorithm basically, or algorithmic basically step, look into that. All right, the second type of solutions called heuristic. So in heuristic solutions, solutions that can be reached by following a direct set of steps. Okay, so when we have a set of problem that cannot be determined or cannot be solved by a set of step, we use heuristic. So this basically has some intelligence to the software. Okay, the software can somehow use some sort like knowledge, okay, some sort like experience, by learning certain heuristic or pattern in the in developing the solution. Okay, so this is basically, for example, determining which stock is the best value. Okay, so for example, we have no idea in the stock market, okay, in KLSE, right? So the software should determine which stock that has the highest probability of providing what we call as the margin of you want to get the what we call it in to determine that which stock that can give you benefit or can give you more return, but it will not always provide the correct one. It will determine either this stock or the other stock based on the data provided. So it will basically analyze the data and then trying to look at the pattern of the data. So for example, if one company stock, we call it as Petronas stock. Okay, so Petronas stock, so to determine either the stock will increase or decrease or go down, so the software will try to analyze the previous data, and then based on the data it try to tell the user, okay, the stock may be increased, okay, but it is not ultimate, it is not solutions, so the result may not produce the same, okay, it is not determined. So most of the artificial intelligence software use this type of solutions, okay, such as robotic, okay, when they're trying to walk on the stair, so the robot need to analyze the stair surrounding and everything with a lot of information, analyze, understanding the environment before it can move to the step or climb the stair. Okay, so more on AI. All right, so basically you do this every day. Okay, so in our class we are looking into the first type of solution, the step solution. So we do this next and next until we solve the problem. So basically there are 6 steps in problem solving, so in your life even. So we do this, okay. So the first thing is you need to identify what are the problem, what is the problem in you're trying to solve, okay. So first, identify, you need to know what are the problem that you want to solve, okay. So identify that. So if you don't know what the problem is, you can't create a solution for it, right? So the problem may comes from user, okay, or either from you yourself. You have problem doing this, you do certain things many times, but you need to find a better solution to do that task, because that is a repetitive task that can be programmed, you can turn into a program. So you need to provide a solution. So if user come to you, so they have this problem, they want you to develop a software that can solve their problem, okay. So identify the problem. For example, calculate payroll for 10 employees, yeah? So you provide directions to certain location in your application. So you need to get the problem first. Second step, so once you've given with the problem or you have the problem, you need to scrutinize the problem, you need to understand the problem, okay. So must understand what is involved in the problem before you can find the solutions, okay. You need to do some research, you need to look at, is there any previous solutions that can support the problems, okay. So you need to find or identify or do some research based on your own knowledge, or you can use internet to look for any known solutions. All right, so that is one. The second thing is that you can do some observation of the current system that is being implemented, okay. So you need to watch, you need to look at, for example, if in one company they have problem key in customer data in Microsoft Excel, for example. So it takes time for them to search for user, or maybe they have a manual filing system, right? So this may takes time for them to update data in the file. You need to do this manually. So you can see there's a problem there. So you can observe the process of translating that manual system into a digital system. So you need to watch their current activity. What are the process that they have done in the manual system before you can translate into a digital software. So review past activity, the one that have been done in solving the current problems, okay. For example, giving instruction to someone on how to find an address, so that is basically for the finding certain GPS location, certain for example, if you want to go to Simant, okay, so someone give you the instruction, so you have to go here first and then here, next. So for that is just for a simple example. So look in the current activity or in the past activity. Third step, so basically once we have look into the current practice, now look for the alternative way. Is there any alternative way to solve the problem, okay. So you can see that, okay, now the company rely on manual system. So is there any way, yeah, you can translate that problem or that current activity into a digital software, okay. So identify an alternative way to solve the problem. So in your daily life, or it is also the same, okay. So you need to, can I do this, is there any way that I can do this better, faster, more efficient? So we are looking into that. So rarely does a problem have only one solution, okay. So basically in your life, basically if there's a problem, you can do it more, you can tackle that problem from different way. Look into efficiency, in terms speed, accuracy, accessibility. So try to address the problem differently, try to think outside the box, right? But that solution must be efficient, must be speed, accurate, the data must be accurate, and it can be acceptable by everyone. And then select the best way. So once you have found several way, trying to what we call as trying to look into what is the best way, which one is the best way from all the alternative solution that you have proposed. Okay, get some criteria. Okay, this one is better in performance, this one is better in efficiency. So look into that, sorry, look into that. So establish criteria, so you can do some metrics, and then you just mark, okay, this solution has better metric compared to the other solution, so you can choose that. You can get the pro and cons of each of the solutions. So that is the fourth way, the fourth step. Then look into that. So you can also do this, determine the best solution based on your research. Look into uh, your current finding, you look into your current problems, and then or you do some research through the internet. Step number 5, list instruction that enable you to solve the problem using the selected solution. So once you've chosen one of the solutions, so you can start to do what we call a step-by-step instruction. Okay, to do this solution, these are the things of instruction that I need to do. Okay, first, second, third, fourth, next, until you solve the problem. Okay, so create a numbered step-by-step instruction, and then that instruction must be included in the knowledge base. So what are the knowledge base? Okay, so basically a knowledge base is when we look at the steps, that step is translatable. You can translate that step into a computerized instruction. Okay, so this can be, we're going to learn this later, how to determine the step and what step are computerizable or what step cannot be computerizable. Right, but this must be based on your programming knowledge, your knowledge base. And the last step, evaluate the solution. So evaluate the solution, test the solution, are the result accurate. So once you've done with the steps, you've done all the steps, and then you need to do some evaluation. Okay, so either your solutions produce the result, does it satisfy the client, does the client happy, is it acceptable to the client, does the solution solve the problem, right? So do the evaluation. So this is basically steps involved in software development also. Even it does solve everyday problem. Okay, so it basically the same with what we call is in software development, they have this what we call as SDLC, the software development life cycle. So basically it follows the same principle in solving the problem, right? So the translation or solving problem with computers, so basically it follows the same idea. So when we have problems that can be turned into computer software, so we look at some definitions. Okay, so solutions, this basically instruction followed to produce best result. So when you have a solution, basically it is a series of instructions, that can be followed, the step can be followed to produce the software. Okay, the result, this is basically the software itself. Okay, so the computer codes or the program, that is basically the result. And then the program itself is this instruction that implement all the steps provided or the algorithm provided in the previous step. So this is coded into computer language. So this is basically the same with the sixth step, but more into software development, or what we call as software development life cycle. So the first step is analyzing the problem, and then we look into algorithm. So we translate the problem into algorithm, and then from the algorithm we turn into programming, turn into codes, and then finally we test the codes. Either the code followed the user requirement, it solved the user problem or not. Okay, so the step in developing a program or building a program: problem analysis. Before writing any program, a programmer must clearly understand the problem. The same. Okay, so programmer need to understand what are the problems, what are the input that needed to be used by user, and then also the output that needed. Okay, so for example, if you try to calculate the BMI, body mass index, so the input from the user, so you need to get the height, the weight, so that input will produce the BMI value. Okay, so what are the output? The output is basically BMI value. So you need to determine that problems, you need to analyze the problem, detect, look for problems, look for input, and then the output. Okay, list that in the problem analysis. Okay, so in the analysis, it start by answering all these questions: what are the input, what are the output, and what are the formula or process that you need to create to solve the solution. So it can be some mathematical calculations, formula that you need to use in your software. Is there any conditions? Okay, so for example, in BMI, so user might want to get value in what we call it, metric value, or some might want to have an imperial value. So that sort of conditions that need to be looked into, addressed into. So these are the things that you need to look into. What are the input? So user input the data, what type of input needed, and then the process, basically the mathematical, for example, some mathematical modeling that will turn the input and process that data, and then from there you get the output, the result that needed by the user. Okay, so you have input, you turn that input and then process into output, and then you need to write some algorithm. So algorithm basically describes step by step. This is not the source code, not the programming, but basically the description of the step. Okay, or what we call as a pseudocode or flow chart. So this chart basically describes the steps. Okay, so need to identify the basic step clearly in correct order from what you found in the analysis step. Okay, so this comes from the analysis step previously. Once you identify your input, your processing and output, so that is basically the pattern that you need to look into. So you determine the input, so your algorithm will start input the following number, input height, input weight, and then calculate BMI, and then the last one is return the value. Okay, produce the BMI value. Okay, and then you need to verify, you need to look into the algorithm. This is basically hand trace, there's no programming yet, right? So you need to write on a paper and then look into all the required value, input value and the output value needed in the algorithm. And then you need to test the algorithm. So you need to pretend that you are a user and then input the data to your software. So you need to look, okay, is there any missing variable needed in the algorithm? So look into that, check all the required variable. So this basically we look into, or you look into hand trace of the solutions. And then you can, after that you can start to code. You need to translate the algorithm into computer coding. Alright, so you can use any programming language, Java, Android, etc., etc. So this of course you need to learn. So this is the thing that you're going to learn in the next topic. Okay, you can use Eclipse, NetBean, so any IDE that can facilitate you to develop the software. Finally, you need to test. Okay, once you've written the software, you need to test with the input and then the output. Either it satisfies the requirement that you have identified. So test to verify that the program meets the requirement by creating test case. So you need to have some scenario for your program. So what happens if you enter alphabet in a number field? Okay, so you need to have test. You need to test any possible error that might encounter, because user, they might enter some gibberish data to your program. So you need to test that properly so that your program is error free, right? So you need to look into this. Program also need to be maintained by modifying if there's any problem arise in the future. Alright, so we're going to look into algorithm in more detail. So again, an algorithm is a clear step-by-step sequence of instruction to solve a problem. So for example, a recipe. Okay, this can be referred in the next slide. So in mathematics and computing, an algorithm is a procedure. Okay, it is a procedure or finite set of well-defined instructions. So for accomplish some task which given an initial state will terminate in a defined end state. Okay, you have begin, you have end. So you start, provide with all the value, process the value, and terminate and produce the result and terminate the software. Something like this. So step one, if you like to bake some cake, okay, so heat the oven and then gather all the requirement, all the ingredient, and mix all together, pour it into the baking pan, put it into oven, and then wait until the cake cook, bake and cool before cutting. So these are all the steps identified. Right, so basically algorithm comes from a Persian mathematician called Abu Abdullah Muhammad ibn Musa, or we call it as Al-Khwarizmi. We know him by the name of Al-Khwarizmi or algorithm. Okay, so basically there are two ways to represent algorithm, either by using what we call as a pseudocode. Pseudocode is basically an English-like statement. It is not a programming statement, it is English-like statement that tells the process, the steps. Or you can use flowchart. The flowchart, you can use some diagram, and this diagram basically tells the step by step to solve the solution, or if there's any bifurcation that describe any choices, left or right, okay, yes or no. So in pseudocode, basically statement using perform input, output, process. Okay, so you have input, process, output. Input, process, output. For example, arithmetic. So you have A plus B equals C. So when you have two input A and B and then one output, plus is the operation. Simple as that. So the input statement are to get the data needed. So for example, student system, you need to get the name of the student mark, or you want to calculate box area, you need length, width, height, or loan amount. So you need to determine the interest rate, loan duration. So this kind of input really need to be identified. And then what are the output needed to display for the user or to print out to the user? So for example, you want to request for user name, so you need to tell the user, okay, please enter your name, please enter your interest rate, please enter length, width, height. So that kind of information for the user to get or to understand that they need to input something into the application. Processing part, this is where the algorithm turn into processing. Okay, so when you want to get certain value, so you have, for example, A plus B. Okay, so C is equal A plus B, or price average press 1 2 3 4 5, divide by 5, or the volume. So these are all the formula that being used to process. So we can just put something like this into the pseudocode. Okay, so this statement represent arithmetic assignment statement. The right side of the statement is the arithmetic expression. Okay, so the other way around. It's not like a plus b equals c, but b is equal a plus c. The other way around. BMI, weight, divided by height times height. Okay, so the left side is where the result is. So this is the result, this is the formula, the operation. So for example, so pseudocode to calculate the perimeter of rectangle. So we can start, so the algorithm start with this start, and then output to the user this, and then get the input, output the rectangle width to the user, and then get the input width, and then do the processing, calculate perimeter, and then output back the perimeter. So this is not programming code. This is basically English like code that tells you the step. So 1 2 3 4 5 6 7 8, there's 8 steps here involved to solve to calculate the perimeter of a rectangle. Or you can turn that into flowchart. Okay, so basically flowchart is a graphical way of depicting a problem. So you can turn that into this graphical output, graphical design. So basically rounded rectangle is start or end of a program. Parallelogram, this is basically input and output. There's a slanted square there, a slanted rectangle. And then you have rectangle, this is for processing. Diamond, this is for decision. Arrow is the execution flow. So for example, calculate the perimeter of rectangle. Start, input length, perimeter, this is the processing, this is the input, this is the output, and then stop. Alright, so this is by use of flowchart. So it is much shorter compared to the pseudocode.